We are one step closer now to completing the engine of our LLM, which means implementing the self-attention class that is going to be used in chapter 5 when we are pre-training the LLM. Now, one more concept we are introducing here is a so-called causal attention mask, and the purpose here is hiding future words. But before we get to the hiding of future words, just to recap the big picture view here of what we have done so far in chapter 3. So before, at the beginning of this chapter, we implemented a simplified self-attention class for mainly educational purposes to illustrate how self-attention works. And then we extended this with these trainable weights to implement the real self-attention mechanism that is then going to be optimized in the pre-training. But on top of that, we are going to modify the self-attention mechanism, adding this causal attention mask that hides certain words inside the mechanism. So to illustrate what I mean, I have a figure here. So before we computed all these attention weights as shown here. If we have an input, your journey starts with one step. What is happening is we are computing the attention weight for each combination of the input with itself. So for example, if we have the sentence your journey, and then the LLM is supposed to generate the next word. Let's say the next word is starts. One thing that happens is when we are generating the word starts, it has access to all the words in this input. So even though it hasn't seen, let's say, future words, like with one step, for example, it has the attention weights for these future words. And maybe to make this a bit more, let's say, simpler to follow, let me type this here. Your journey starts with one step. So when we have input text like this, like I explained earlier in chapter 2, we want to train the LLM to generate one token at a time. So the first token it might see is your, and then it's supposed to generate journey, right? So and when it's supposed to generate journey, it's not supposed to see those tokens yet. So they should be hidden. And so in order to accomplish that, we have to mask them, because during the pre-training, this is available because we have this in our training set, but we don't want the LLM to see that yet. We only want to see, or we want the LLM to see only the next token. So what we're going to do is we're going to mask out all these values here so that when the LLM receives the second input journey, it cannot really see anything beyond that. So it's really when it's supposed to generate the token starts, it's not seeing these other tokens in the input. We are hiding it. So it's essentially a modification to the self-attention mechanism to hide future words. So how are we going to do that? So let me show this in code, and we are going to use, for simplicity, let's use those things here. So we implemented previously the self-attention version 2 class, and we are going to use that just to keep it a bit simpler so that we can modify it, because we are going to create a modified self-attention class that is then the causal self-attention class. So just to play around with this for a bit though, before we implement this class, let me just do it like this. And then of course I have to use this here instead of self. Okay, let's see if this works. So now we have computed these attention weights. And these attention weights are the ones you are seeing here. And we are going to mask everything above the diagonal now. So one way we can do this is by creating a mask. And so this mask, I just copied the code here. It's torch trill. So in this torch trill, based on ones, it will create this triangular mask here, essentially, where we have ones below the diagonal and zeros above the diagonal. And then what I can do, very simply, is I can take this one and multiply it by mask simple. And what will happen is if we multiply a value by 1, it won't change. But if we multiply a value by 0, the value will be zeroed out. So let's call that masked simple. And then we will print out how it looks like. And so now you can see we masked these values. So in the first row, everything but the first value is here is zeroed, so they're all 0. And then in the second row, we have the 2 tokens here, and everything after the 2 tokens is zeroed out. Now, one thing you might notice that has changed is that now the values in each row, they don't sum up to 1 anymore, right? So, and it is actually good for optimization purposes to have them sum up to 1. So what we can do is we can use our normalization that I introduced way back early in this chapter, just using the .sum method, and yeah, then essentially divide each value or each row by the sum of the values in each row. And mathematically, this should come out as normalizing these values so that they sum up to 1. We did that earlier. I think it was earlier in this chapter where we used a similar method. So that was before we introduced the softmax. So what we have now is we have normalized it such that each row now contains, again, values that sum up to 1. And I do think I have a nice figure here somewhere. Yeah, here. So what we have done so far is we took the unnormalized attention scores. So if I go back, we have the attention scores here. Then what we have done is we computed the normalized attention weights. That's with the softmax here. And then we computed the masked values, which is what we have done here. And then we normalized those so that they sum up to 1 again in each row. And that is what we have here. So that is one way we can do that. So now we have things that sum up to 1 in each row again. So that is one way how we can compute this mask here. So this is what we've just computed. Now, there is actually a simpler way. So this is 1, 2, 3, 4 steps. There's one simpler way of accomplishing exactly the same thing. And that is a little trick here. I should have a figure on this here. So what we can do is instead of computing the softmax and then masking and renormalizing, we could actually do this in one go. So where we have the attention scores, they are unnormalized, and then we mask them. Instead of applying the softmax, we mask them. So before, just take one step back here, before we applied the softmax and then mask them, now we are doing it the other way around. We are first masking it, and then we are computing the softmax. And so this is only 3 steps. It's a bit simpler. So that is one trick if you are familiar with, let's say, some basic math concepts. This is one trick we can just make it a bit simpler. So I'm again, to show you how this works, I'm again creating a mask here. So this mask has now -inf values above the diagonal. And so -inf is stands for negative infinity. It's a very small number, like -999999999 and so forth. And if you are familiar with some basic math concepts, if you take e to the power of a very small value, like a negative value, let me try this like this maybe. This should be close to 0 essentially. Oops. Torch X. Oh, it should be a tensor. One moment. So that's one thing when working with PyTorch. Yeah, so you can see it comes out as 0, and it's the same one as if I would do it like this. I think this one should work. Oh yeah, the same problem again. Tensor. Oh yeah. I have a double inf. I have a minus here and a minus here. So either this one or this one should do the job. So what we have, so what I'm showing you here is what we have here. So the -inf. And if we take the exponent of that, it comes out as 0. And if you recall previously when we implemented the softmax, let me search for this. Here. So you can see we computed like this here, like the exponent, right? So what we're doing is we are taking a shortcut based on this mathematical property, and we are now computing this mask and apply this mask directly to the attention weights. And then what we do is we can compute the softmax again. So let me do it here. So this is the same softmax function we used before. If I scroll up again. So right here. So you can see this is the same thing. Except now we are going to apply to the mask the values instead of the attention scores. But this part is essentially the same. I could also make it more consistent, a bit like this. And this should give me also the masked attention weights. And these are exactly the same masked attention weights that we have seen earlier here, except now it's one less step. So now we only have 3 steps instead of 4 steps. And so yeah, this is our causal attention mechanism. And yeah, later on we will also add this to our causal attention class, the compact class. But I want to introduce one more step in the next section before we actually modify our compact self-attention class.
Get this book at Manning.com.